Welcome to the spoken tutorial on functions and types. In this tutorial, we are going to learn how to define a function, how to use algorithm, how to define a type. To record this tutorial, I am using OpenModelica 1.9.2 and Ubuntu operating system version 14.04. But this process is identical in Windows, Mac OS X or Fuzzy OS. To understand this tutorial, you need to know how to define a class in Modelica. You need knowledge of functions in any programming language. Prerequisite tutorials are mentioned on our website. Please go through them. Let us discuss a function now. Function is a specialized class that can take input and return output. It contains algorithm section. A function cannot contain equations and it cannot be simulated. The syntax of a function is as shown. Now let us write a function named polynomial evaluator which takes x as input and returns f of x equals ax square plus bx plus c, where a equals 1, b equals 2 and c equals 1 as output. Polynomial evaluator file is available on our website. Please download and save all the files available in code files link. To demonstrate polynomial evaluator function, let me go to OM-Edit. OM-Edit is now open in welcome perspective. You are only seeing a part of the OM-Edit window. Since I have zoomed in, I shall show you the relevant portions by shifting the window whenever necessary. To open the files that you have downloaded, click on Open Model or Library File tool. I have saved all the files in a folder. Let me select them together and click on Open. If you have saved these files in different folders, you may open each one of them individually. Note that the following classes or functions are now open in OM-Edit: bouncing ball with user types, function tester, multiple function tester, multiple polynomial evaluator, and polynomial evaluator. To open polynomial evaluator function and view it, right click on the icon in Libraries browser and select View Class. If the function does not open in text view, open it in text view. Name of this function is polynomial evaluator, as we have already discussed. X is a real variable. Input is a keyword which is used to specify input variables. Similarly, output is a keyword which is used to specify output variables. Fx is a real variable which represents f of x. Any variable or parameter which is neither input nor output is specified using protected keyword. A is a real parameter with a value of 1. The values of A, B and C are as discussed in the slides already. Please note that A, B and C are protected parameters. Algorithm represents the beginning of algorithm section of a function. Algorithm section may contain assignment statements only. This sign indicates assignment. In an assignment statement, the value of right hand side is assigned to the left hand side. The left hand side is usually an unknown expression. In this case, fx is an unknown variable. The value of right hand side expression here can be calculated if the value of x is known. X is usually passed as an input argument to the function whenever it is called. Now let us see how to call a function using function tester class. Function tester icon can already be seen in Libraries browser since I have already opened it. To open this class, double click on its icon. This is an alternative way of viewing a class. You may also right-click on its icon and select View Class. Z is a real variable. Polynomial evaluator function is called with an input argument of 10 units and it is equated to Z. The input value variable of polynomial evaluator, that is x, takes a value of 10 units. Now let us simulate this class. To simulate this class, you may right-click on function tester icon in libraries browser and select Simulate. The class has now simulated. You may also use the Simulate button in toolbar to simulate a class. Now let me show you the plotting perspective completely by shifting OM-edit window to the left. Select Z in the variables browser. Note that the value of Z is equal to the value of f of x at x equals 10. Now let me deselect Z and delete this result. Let me go back to modeling perspective. Click on Polynomial Evaluator tab at the top. Notice that Polynomial Evaluator function has only one output variable. Now let me show you how to output two or more variables using a function. I have created a function named multiple polynomial evaluator which has two output variables. Before viewing that function, let me close the tabs of polynomial evaluator and function tester. Since the libraries browser is not visible, let me shift the window to the right. Double click on multiple polynomial evaluator, multiple function tester, and bouncing ball with user types. Shift the window back to its place. Go to multiple polynomial evaluator tab. This function is similar to polynomial evaluator function except for an additional output variable. An output variable named gx has been declared. Gx is assigned the value of ax square minus bx plus c. The order in which output or input variables are declared is important. We'll understand more about this when we discuss multiple function tester class. Now let me switch to multiple function tester tab. Y and Z are declared as real variables. Multiple polynomial evaluator function is called with an input argument of 10 units. This means that the input variable of multiple polynomial evaluator takes a value of 10 units. Y and Z take the values of f of x and g of x at x equals 10 respectively. Y takes the value of output variable fx since the declaration of fx appears before the declaration of gx in the function. Now let me simulate this class. Click on Simulate button. Close the pop-up window. Select Y and Z in the variables browser. Note that the values of Y and Z are the same as f of x and g of x at x equals 10 respectively. Delete the result and go back to modeling perspective. Now let me interchange the order of Y and Z. Delete Y, Z and type Z, Y and save this class by pressing Ctrl plus S. Simulate this class once again. Close the pop-up window. Select Y and Z in the variables browser once again. Note that the values of Y and Z have been interchanged as compared to the previous case. Let me delete this result and go back to modeling perspective. Let me go back to the slides. Algorithm is Modelica syntax element to enable procedural programming. Only assignment statements are allowed in algorithm section. Assignment statements use the following symbol. Data flows in assignment statements from right to left. There are certain restrictions on functions defined in Modelica. Use of DER in a function is invalid. Use of time variable is not allowed. Use of when statements is not allowed in a function. A function may not have more than one algorithm section, and models cannot be passed as arguments. Type is a specialized class to define custom data types in Modelica. For example, physical quantities like velocity and current can be defined as data types. They can be used later to declare other variables. Attributes of Modelica data types like unit and start can be changed accordingly. For example, in the above case, velocity is defined to be the same as real data type with its unit modified to meter per second. I have created a model named bouncing ball with user types to simulate type definitions. Let me go back to OM edit to demonstrate this model. Click on bouncing ball with user types tab. This model is similar to the bouncing ball model which was discussed in previous tutorials. Please go through the prerequisite tutorials to understand bouncing ball model. Length is defined as real data type with its unit modified to meter. Similarly, velocity is defined as real with its unit modified to meter per second. H represents height of the ball from surface of Earth. It is defined as length data type. Similarly, V represents velocity of ball. It is declared to be of velocity data type. Remaining variable declarations and equations of this model are similar to bouncing ball model. Now let me simulate this. Close the pop-up window. In the variables browser, notice that H and V have their respective units associated with their data types. Let me select H in the variables browser. The plot of H versus time is similar to that of bouncing ball model. Let me deselect H. Now let me go back to the slides. As an assignment, breach the restrictions on functions and observe the errors produced. This brings us to the end of this tutorial. Watch the video available at following link. It summarizes the spoken tutorial project. We conduct workshops using spoken tutorials. Please contact us. If you have questions in the spoken tutorial, please visit the website. We coordinate coding of solved examples of popular books. Please visit the website for more information. We help migrate commercial simulator labs to Open Modelica. Spoken Tutorial project is supported by NMEICT, MHRD, Government of India. We thank the development team of Open Modelica for their support. Thank you.